Hey guys, it's Devin, and today we're going to cover factoring a quadratic expression with a leading coefficient equal to 1. This is going to be the first video of a series on factoring quadratics, so check out the other videos because it will build upon this one. So let's take a look at the general form of a quadratic expression. It's given by ax squared plus bx plus c. And let's get familiar with the terminology you can expect to hear in these videos. We generally list our highest power term first. Because this is a quadratic, our highest power is 2. And we normally list our terms in descending order by their power. We refer to our power to give the degree of the term. Here we see that x is raised to the second power. Because this is our highest power in our expression, we can call this our leading term. Also, because our exponent is 2, we can call this a second degree term. Here, x is raised to the first power, although we don't show it like the previous term. We can call this our first degree term. Here we have a term without a variable. This is just some number and we call it a constant. These constants here, a and b, we call these coefficients because they're multiplied by a variable raised to a power. Right here, because this coefficient is multiplied by our highest power term, we can call this our leading coefficient. And because we're working with the simplest case of a quadratic expression, our leading coefficient is just going to be equal to 1. So for starting out, I'm going to give you some rules to follow that will allow you to factor these quadratics correctly. I usually make it a point to explain why a method works first, but for this topic I will skip that and help you first get comfortable with factoring. We'll explain the concept and why these rules work in the next video, so please check that out. So the rules are: 1. We identify the constant term in the quadratic expression and we determine all of its factors. Here we have our constant term. We're calling it capital C. Let me just underline that if I can get my pen to work. So here our constant term is what we're calling capital C, and we're looking for its factors. In other words, we're looking for the combination of two numbers, all those combinations of two numbers that multiply and equal C. Let's go ahead and call these numbers a and b. So we're looking for values a and b multiplied together that are going to equal this capital C. Our second rule or condition is that we're going to add all the factors that we found for our constant term, and we're going to identify which pair adds up to the coefficient on our first degree term. Our coefficient on our first degree term is what we're calling capital B here. So in other words, what we're doing is we're taking all these values of a and b that multiply and equal our constant term, and we're taking them and we're summing them, so we have a plus b, and we're looking for the ones that add up to our first degree term's coefficient, which is capital B. The values of the factors that satisfy both of these rules will be the constants in our factored form of our quadratic expression, which is given below, right here. So our factored form will be the product of two linear factors. Here we have a linear factor here and another linear factor here. We also call these binomials because these parts have two terms. Again, our values that we determine using our rules will be substituted for the values a and b here. So let's go ahead and use our rules to factor a few quadratics together. So our first rule was we're looking for all the factors of our constant term. Well, that's just going to be 7. And we're looking for all the combinations of numbers a and b that multiply to 7. So we have a times b equals 7. And we're looking for all the factors that add up to our first degree term's coefficient, which is going to be 8. So we're looking for the values a plus b, which equal 8. Now let's go ahead and organize this with a table. So all the numbers that multiply out to 7 are 1 and 7. 1 times 7 equals 7. We also have that negative 1 times negative 7 equals 7. And let's go ahead and add these up. So we have 1 plus 7. Well, that's going to equal 8. That's exactly what we're looking for. So we can say that a can equal 1 and b can equal 7. And if we plug these into our factored form, which was x plus a times x plus b, then we have x plus 1 times x plus 7. And this is going to be our factored form for this quadratic expression. Now let's go ahead and just double check our work just to make sure it's correctly. What we're going to do is we're going to expand this product, so we have x times x, which is x squared, x times 7, well that's just going to be 7x. We have 1 times x, which is just going to be x, and we have 1 times 7, which is 7. And if we combine like terms, we have x squared plus 8x plus 7, which is exactly what we have here. So we can say with confidence that this right here is going to be the correct factorization of this quadratic. Let's go ahead and do a couple more. So here we have n squared plus 4n minus 12. Well, we're going to be looking for all the values that we can multiply together that give us negative 12. Again, that was a times b is equal to negative 12. And we're also looking for the values a plus b from our factors that add to this 4. Let's go ahead and make another table. So for the factors of negative 12, we have 1 times negative 12. That equals negative 12. We have negative 1 times positive 12. That also equals negative 12. We have 2 times negative 6. We also have negative 2 times positive 6. We have negative 3 times 4. We also have 3 times negative 4, which equals negative 12. And that's going to be it. So let's go ahead and take our factors and let's add them together and see if we can come up with positive 4. Well, 1 plus negative 12, well that's just going to be negative 11, so that's not what we're looking for. Negative 1 plus 12, well that's going to give us positive 11. 2 minus 6, well that's going to give us negative 4. And if we take negative 2 and we add 6 to it, then we get positive 4. And this is what we're looking for right here. So our values for a and b are going to be a equals negative 2 and b equals positive 6. Let's go ahead and plug that into our factored form of our expression. So that's going to be x plus a times x plus b. So what we can say is that x plus a, well a was negative 2, and over here we had x plus b, and b was 6. We can simplify by getting rid of the parentheses, and this is just going to be x minus 2 times x plus 6. And let's just go ahead and double check this by expanding out this expression. So let's see, we have x times x, which is x squared. X times 6, well that's just 6x. Negative 2 times x, well that's just negative 2x. And negative 2 times positive 6 is going to give us negative 12. Combining like terms, we find that this is going to be x squared plus 4x minus 12. And sure enough, this is the same as this expression. You know what? I just realized I changed variables here. Sorry about that, guys. So these were supposed to be n's this entire time. So here, let me just go ahead and fix that. So n here. Okay. So by expanding our expression, we got back to our original answer, which was up here with this expression. So we can say that this right here is going to be the correct factorization of our quadratic. Okay, so let's go ahead and move on to our next example. We have m squared plus m minus 90. Okay, this one's going to have quite a few factors. So again, we're looking for all the factors that multiply out to negative 90. So that's going to be some value a times some value b, which is going to equal negative 90. We also have a plus b, which is going to equal our first degree terms coefficient, which is really just a 1. There's probably going to be like 8 or 9 different factors for this problem, or different combinations that we can consider. But notice that we're looking for the factors that when we add them together are going to give us a positive 1, and we have its product, it has to equal negative 90. I'm going to go out on a limb and I'm going to say, okay, well, let's think about this. What factors are close together that multiply out to negative 90? Well, one could be negative 9 times positive 10. That's going to equal negative 90. We also have positive 9 times negative 10. Well, that's going to equal negative 90. And we're looking for the one that equals 1. Well, negative 9 plus 10 gives us positive 1. So here our values a and b are going to be a equals negative 9 and b equals positive 10. Let's go ahead and plug that into our factored form, which was again x plus a times x plus b. So for a we have negative 9, and for b we have positive 10. Let's go ahead and simplify by getting rid of these inside parentheses. So this is just going to be x minus 9 times x plus 10. And let's go ahead and expand this and just make sure that it does indeed equal our original expression. Darn. You know what? For some reason, I'm so used to writing x that I keep forgetting that these variables don't have x's, or these expressions don't have x's in them. So this should be an m. This should be an m. This should also be an m. And same here. Okay. So let's go ahead and expand this and just double check that it equals our original quadratic expression. So we have m times m, well that's just going to be m squared. M times 10, well that's just 10m. Negative 9 times m, well that's negative 9m. And negative 9 times positive 10 is negative 90. Combining like terms, we have m squared plus m minus 90. And that's exactly what we had when we originally started. So we can say that this right here is the correct factorization of our quadratic expression. So that's it for this video. If you found this helpful, please click on the subscribe button so you'll be notified when new videos are available.